Hey guys, how's it going? Yeah, we're just gonna get going on this absolute value homework slash classwork slash whatever your situation is, because some of you have to be at home doing this. I know it's unfortunate, but kind of the way it is. This is the work that's supposed to be due Friday at midnight. However, if you need an extension, just go ahead and email me. Shouldn't be too big of a problem for us just to go through it. Yeah, let's get going. I'm not going to use the calculator while I go through this, but you're always allowed to use the calculator on this stuff. I kind of showed you the last time. You can use Desmos, you can use Wolfram Alpha, use a Google calculator, whatever makes you happy while you're at home. Or if you're in my class, you're always allowed to use those 84s that are available. Let's hop to it. So reminder, solving each equation here, this is an absolute value. An absolute value means distance. So it's saying the distance from m to 0 is 10. There are two possibilities for that answer. M can be equal to 10 or m can be equal to -10. So this one's kind of just a freebie. Starting off at number 2, we now have our first problem where we have two things that we have to go through. Because there's a 9 on the bottom over here, and it's just a single absolute value, we're going to go ahead and immediately multiply both sides of the equation by 9. Multiplying both sides of the equation by 9, because it means the same thing as division, will make these two guys effectively cancel out because 9 divided by 9 is 1. Don't need to write a multiply by 1. And we get the absolute value of x is equal to 27. And now it's just like this question, two different answers. X is 27, and we can be even lazy and just write -27 with a comma separated between the two. Let's continue going on to number 3. So on number 3, similar to number 2, where we had to multiply both sides by 9, now we need to divide both sides by -7. We're trying to get the absolute value alone on both sides of the equation, and we end up with this absolute value of k is equal to 2. It's a positive 2. And again, just like the previous two questions, we'll split it into two problems. K is equal to 2, and k is equal to -2. Keep it moving. All right, number 4. So number 4 is the first problem where we have stuff to do on the inside of the absolute value. Whenever that happens, it's just when you split them into two separate questions, you have more work to do after solving. So, or until you solve. N plus 10 is equal to 18, and again, n plus 10 copied to be -18. Finishing this guy up, we're going to go ahead and subtract 10 on both sides for both equations. So one of our answer is 8, and the other answer is going to be -28. And my face is just barely not covering that one. Good to see that. Let's keep it moving. Problem number 5. Problem number 5, again, we split this guy into two. We get x minus 10 is equal to 14, and x minus 10 is equal to -14. Add 10 to both sides. Oops, I did it to both equations instead of both sides. And now we get x is equal to 24, and x is equal to -4. Awesome stuff. Continuing on to number 6. Now, number 6 is one of the first questions that often trips people up because there's that fraction with the absolute value, but you want to treat it just like problem number 2, where you multiplied both sides by 9 because you were dividing by a fraction, or dividing by a number, not dividing by a fraction, but dividing to create a fraction. Dividing by a number here, dividing by 2, we're going to multiply both sides by 2 as our very first step to this question. So we're multiplying both sides by 2. I know my 2 times is not very good there, but the idea again is that these cancel out for each other. We get n minus 2 is equal to 6 with those absolute values around it. Split that guy into two problems. N minus 2 equals 6, and n minus 2 equals -6. Add 2 to both sides. We're going to get n equal to 8. N is equal to -4. Gotta make my arrows a little bit smaller, easier to read these problems. Let's continue moving on to problem number 10. So problem number 10 might be one of the first questions where it's appropriate to use our letter U if you really wanted to. However, I'm going to wait until problem number 10 to do that. So you're trying to get the absolute value alone first, just like in those previous questions. We're going to subtract 10 on both sides. Again, if you want to use the U here, this is probably the first one where it's really not a bad idea. If you did use the U, you'd end up back at this step anyways, so it's not that big a deal. Split this into two separate questions. We got x over 5 equals 2. X over 5 equals -2. We're multiplying both sides by 5. I'm not going to show the work because I want to keep the show on the road. We're multiplying both sides by 5, and you'll get 10 and -10. Keep it moving. Number 8 is just like number 6. We'll start off by multiplying both sides by 7. And now, this is your chance to kind of see that you don't need to show as much work because we've shown the multiplying by 2 on both sides and the canceling, shown the multiplying by 9 on both sides and canceling. Let's just not show the work this time. We're multiplying both sides by 7. We know we're multiplying both sides by 7, and those 7s will cancel, and that 2 times 7 is 14. Not showing that work can make your life a happier situation. Split it into two separate questions, and here we go. X plus 2 equals 14. X plus 2 equals -14. Subtract the 2. Subtract the 2. I don't even know why I'm trying to show you not to show work, and I'm showing the subtracting too. What in the world, Mr. Richards? Be consistent one of these days. Maybe one day I'll be consistent. Here we go. Continue on to number 9. Number 9 is our first question that some students don't like because their answer is kind of strange in that it's a fraction. But because this is 9 being multiplied by the absolute value, just like in the problem number 8 when we multiplied both sides by 7 but didn't show our work, we're going to divide both sides by 9 and not show our work. So we divide by 9. And that becomes a 10. Because 90 divided by 9 is 10. Split this into two separate questions. 7v plus 10 is equal to 10, and 7v plus 10 is equal to -10. And here, I actually am going to show the work for it on the -10 on both sides because students sometimes get tripped up because they just don't know what to write because they want to cancel out because they canceled out here, but you're canceling out because it's plus 0. So here it's 0. That's what's happening. And then when you divide both sides by 7, you still get 0. 0 divided by anything else is still 0, with the exception of 0 divided by 0, which we can talk about more at a different time if you'd like to. Talked about it in one of my classes the other day, actually. But anyways, we'll subtract 10 on both sides here, just like on that previous question. I just said I wasn't showing work, and I keep doing it. It's like a habit at this point. And then divide both sides by 7. There we go. We get v is -20 over 7. It's completely fine to leave it as a fraction, or you could plug it into a calculator and I don't know, what would you get? You get -2 4/7, which is no, 6/7. What am I saying? -2 6/7, which is like -2.8 something. I don't know. I don't feel like doing the work, and I'm not going to. All right, so we're gonna go ahead and do our first real U problem. Now this is a great question for the letter U when you have lots of things on the outside and stuff to do on the inside, and there's so many things going on that we want to make U equal to that absolute value to make it not so confusing looking. So U is equal to that R divided by 6. And because U is equal to that R divided by 6, we can rewrite the equation as -9 minus 6U is equal to -18. We're going to add 9 to both sides now. One of these days I'll stop showing work. -6U equals -9. Divide both sides by -6. Many students, when I was doing this question with them in class, preferred for the work to be shown with a decimal. So now we're going to write U is 1.5. And now we combine these two guys because U is R over 6, the absolute value, and it's 1.5. So we can write R over 6 is equal to 1.5. Split it into two separate questions. R over 6 equals 1.5, and R over 6 equals -1.5. And now, finally, I really won't show work. We multiply both sides by 6, so times 6 times 6, and we get R is equal to 9 times 6 times 6. R is equal to -9. Here we go. Let's keep the show on the road. Going on to the next page here. So for you, it won't be like one-sided like this. I just printed it off at home. So yeah, let's go on to number 11. So number 11, yet again, another great chance for that letter U to show up. So U is equal to, and maybe U's not a good choice because that's a V. Let's use we'll use capital C for my name, Carson. C equals the absolute value of V plus 7. So 1 plus 3C equals 16. Now we just have to solve. Careful with this. A lot of students want to do like 1 plus 3 first and get 4. You can't do that because this is being multiplied. Same idea here. You can't do it because it's multiplied. Might help you to put a little plus inside front of that 1 to remind you that you're subtracting 1 on both sides. There I go again, showing the work I just said I wouldn't. Next problem. Next problem. Next problem, I'm not showing it. Poof. It's happening. All right. Anyways, divide both sides by 3 for this next step. C is equal to 5. Then we're going to go ahead and combine these two, just like we did in that last question. So the absolute value of V plus 7 is equal to 5. Split it into two separate questions. V plus 7 equals 5, and V plus 7 equals negative 5. Subtract 7 on both sides, gets you a negative 2, and it gets you a negative 12. Let's keep it moving. Keep it going. Number 12. So again with the U, negative 1 minus, and this guy's going to be our U. So actually, I kind of skipped a step. Should have written U equals 4 minus 5x equals negative 20. Technically, some students are asking me, do I have to write that? And it's one of those things where it's good to get into the habit of it because you don't want to confuse a future teacher because this is not a topic that's taught until calculus. So it typically is not something that you do until you get to a higher level of math. So I recommend doing this and writing it off to the side if you choose to do it this way, mainly to make sure that you don't confuse a future teacher. Yeah, that's my opinion. Now we're going to add 1 to both sides and we're not showing the work. We're adding 1 to both sides. We're right. Negative U equals negative 19. One of those cool rules that we learned last time is if you have a negative on both sides of the equation, you can just make them both positive by multiplying both sides by a negative 1. So you get U is equal to 19, and U is equal to this, U is equal to that. Combine the two guys. 4 minus 5x is equal to 19. Split them into two separate questions. 4 minus 5x equals 19. 4 minus 5x equals negative 19. We're not showing our work. We're subtracting 4 on both sides here. Negative 5x is equal to 15. Subtracting 4 on both sides, negative 5x is equal to negative 23. Dividing both sides by negative 5, we're not showing our work. X is equal to negative 3, and x is equal to 23 over 5. Or if you decide to use a calculator, what would that be? 4.6? Okay. Boom. Finally didn't show our work. Finally remembered that we don't have to show those little subtraction 4s on both sides, the divided by negative 5s on both sides. But if it makes you happy, you do put them. I just wanted to show you this is kind of like probably the bare minimum amount of work to show. You probably could get away with showing maybe 1 or 2 less steps somewhere, but yeah, that's probably the minimum you want to do. Number 13, our last absolute value, true absolute value problem. I want to remind people they don't have to use the letter U. So I've been using the letter U and the C for all these questions, but you don't have to. If you're comfortable with it, you can just do things like adding 9 to both sides of the equation right away. And then dividing both sides by negative 7 right away. And if you can see that that whole absolute value is the letter U there, you don't have to create the letter U to do these questions. So it's like totally optional. Split this into the two problems. 5k plus 5 equals 10. 5k plus 5 is negative 10. Subtract 5 on both sides. I'm back to showing my work. And divide both sides by 5. We're going to get k is equal to 1. Subtract 5 on both sides here. We got 5k equals negative 15. Divide both sides by 5. And k is equal to negative 3. All right, now we're into that review part of the problem. So I put these questions on review because these are the types of questions I thought that students miss the most often. And so I want to kind of make sure that we're staying on top of them best that we can. Here we go. So here's number 14. So number 14, we're going to take that 3 and distribute to both. We get 15 minus 3r equals 8 minus 4 plus 8r. So what happened there was my 3 distributed to both of these and the negative distributed to both of these. Be careful. Don't try to distribute the 8. It's kind of like there's a negative 1 in front of there. It might help you to write the negative 1 and really see that you're distributing a negative 1, not an 8. Add like terms here, so all of this stuff is copied. We're going to move all the stuff with an 8 to the, or all stuff with an r to the left, all stuff without an r to the right. So the negative 3r is copied. That 8r is moved to the left and becomes a negative 8r. That 4 is copied, and that 15 is moved to the right, becomes a negative 15. Add like terms. And divide both sides by negative 11. Get r is equal to 1. Let's keep it moving. Number 15. So we're going to distribute this negative 3 to both of these guys. We're going to get a 3a minus 15 is equal to negative 3 plus 21 and then plus 14a. So you get 3a minus 15 equals 18 plus 14a. And because we added like terms there, my brain just kind of failed. I went and did that question too fast because I don't know if I got tired or what happened there. Distributing that negative 7 to both of these guys is what got me that 21 and that 14. Same thing as that last problem. We're going to move all the stuff with an a to the left. So 3a is copied minus 14a because it was a positive on the right. Here's the 18, taking the 15 over, plus 15 on this side. Negative 13a, negative 11a, oh my, I really am getting too tired. Negative 11a is equal to 15, and this, did I make a mistake? This is not coming out pretty. Let's see, negative 3a, negative 15, negative 3, positive 21, positive 14. No, it is coming out pretty because 18 and 15 is 33, not 36. My brain was... Yeah, I'm done. I'm done, guys. And I still have a whole half a problem to go. What is going on? We get negative 3 when you divide both sides by 11. All right. Finishing it up. Here we go. Number 16. Let's finish this up. We're going to be done. We need to get x alone here. So I'm going to subtract 2 on both sides. So we get x is less than or equal to negative 2. And then here we're going to subtract 7 first. Ax is greater than 16. Divide both sides by 8. And we're going to get x is greater than 2. So we have x is less than or equal to negative 2 or x is greater than 2. So we got a 2 here and a negative 2 there. And we're going to go off to the right and fill this guy in and go off to the left. Those are what those are going. And we have an or, which makes sense to split them up. I'm going to quick pause on my video so I can take a break before the second set of problems. All right, so time has passed for me. It's not passed for you. Hopefully I'm a little bit more awake now. I did a little walk around and did some chores, and now I'm back. Here we go. Let's get the show on the road. We are finishing this up. So this is the same idea as the last stuff, except now we have to have our additional rules of graphing the solution to the problems. So there's a little bit more stuff we got to get going. So again, we're going to split these into 2 questions. And the big part of the rule is going to show up immediately. So we have our x less than 9. And then we have to decide whether it is an and or an or question. So basically, whenever this alligator guy is eating the number, or you could say the alligator guy is not eating the absolute value, whenever your absolute value is less, it's saying a distance is less than 9. So if your distance is a smaller amount than 9, you want to think your distance is smaller. If your distance is smaller than this, it's somewhere in the middle. Because your distance is smaller, somewhere in the middle, it must meet. So it must be one of these and situations. So we have x is less than 9 and x is greater than flips -9. So those are from the notes the other day. You want to make sure that you have those down where we know that it flips around. If it flips on this side, being made negative, and if it's alligator eating number, it will be and. Alligator eats absolute value, be an or. This one doesn't have any extra solving. We can just go ahead and start graphing right away. The graph should be very, very fast. -9 to 9. Put that 0 in the middle and open circles because of those ones. Boom, we're done. Same concepts on almost every single one of these. So let's get going. We have another and situation coming up. I'm not even going to draw the arrows to split them up. -10n less than or equal to 50 and -10n greater than or equal to -50. Divide both sides by -10. Flip the direction of the sign. N greater than or equal to -5. And the word and would be copied all the way down, so I just don't feel like writing it. If you notice, I'm showing that work of dividing by 10, and this is where it would start getting really cumbersome in questions like this. So we're going to divide both sides by -10, and that's going to be a less than or equal to +5. So it's, again, meeting in the middle. We have that -5 greater than going this way, less than 5 going that way. There's that 5 going down, filled in circles this time, and we got those connected dots. Beautiful. Beautiful, beautiful. Finishing it up, let's keep it on. Number 3, splitting into 2 questions. I just said I wasn't going to do the arrows, and I did anyways. X plus 2 greater or equal to 9. This one's an or, because alligator is eating our absolute value. So x plus 2 is less than or equal to -9. And we're going to subtract 2 on both sides. I guess I'll show the work on this one because I drew the arrows. Greater or equal to 7. Subtract 2 on both sides. Less than or equal to -11. And because we have the or, we have greater than 7. That's going to be going this way. Less than or equal to -11. It's going left, so our ors kind of go apart from each other. Number 4, don't know why I made this one easier all of a sudden, but we are going to start by dividing both sides by 7. And we get absolute value of x is less than 5, and actually it's almost identical to this one right here. So all I'm going to say is it's just like this question except the 5s or 9s. So it's the same exact idea. X less than 5 and x greater than -5. Boom, boom. -5, 5, 0. Boom, connect the dots. Has the same answer as this one actually with the ends. It's just, different setup of the problem. Anyways, continuing on, here we go. Number 5. Just like on that previous homework there, when we have the 3 on the bottom right here, we're going to start by multiplying both sides by 3. And when you do that, these 3's kind of go away. They vanish. 3 divided by 3 is 1. So k minus 9. And inside the absolute value still greater than 6. Split it into 2 separate questions. K minus 9 greater than 6. Absolute value eating the alligator is eating absolute value, so you get the or, and k minus 9 less than -6. Add 9 to both sides. Let's not show the work. Adding 9 gives you 15. Adding 9 here gets you +3. So k is greater than 15, or it is less than 3. So we got a 3 here, a 15 there. Open circles. The or goes apart. Bigger than 15, less than 3. There we go. Number 6, could be appropriate to use the u on this one. I'm going to choose not to use the u here. Let's see, unless there's one later that I don't want. Yeah, I'm going to use u's on later questions. So let's use the u on this guy. Here we go. Subtract 10 first. We're trying to get that absolute value alone. Once we do that subtracting 10, we do get the absolute value alone. X minus 8 greater than 5. Immediately create that word or going on it. So we have x minus 8 greater than 5, or x minus 8 less than -5. Want to add the 8 to both sides. Adding 8 to both sides gets you 13. Adding 8 to both sides here is going to get you +3. Again, with that word or being copied all the way down. So 3 here, 13 here. Super similar answer to the last question. Cool. Keep the ball rolling. Number 7. So similar to one of the ones, I believe actually in the same position as the last one, we divide both sides by 3 to start the question. So divide by 3, boom. And you get negative 3a plus 10 is less than 10. Again with the and, negative 3a plus 10 less than 10. And negative 3a plus 10 less than negative 10. Subtract 10 on both sides here. I already started showing work, so I'll show all the work again. Negative 3a less than 0. Divide both sides by negative 3. When you divide by negative, you must flip the sign. A is greater than 0. And subtract 10 on both sides. Negative 3a is less than negative 20. Divide both sides by negative 3. Negative 3's go away. And you get a is greater than 20 over 3, which is just 6.6 repeating. So it's, oh, did I make a mistake? What mistake did I make? A is greater than 0 and a is greater than 20. Does this make sense? Let's catch my mistake. Who caught the mistake early? So subtracting 10, that's nice. Dividing by a negative, I do flip the sign. I didn't flip it when I moved it over here. This side always gets flipped. Greater, greater, less. So I don't know if you noticed that, but I knew I made a mistake because they weren't pointing in different directions. These and ors and absolute values, they'll always point in different directions at this stage of the question. They have to. So definitely made a mistake over here. So we have 20 over 3, and then as a is greater than 0 and less than this guy, so they have to meet in the middle with that and. Telling you, I'm too tired. Too tired. Let's finish this up. Multiply both sides by 2. Those guys cancel. You get 7 minus 2x less than 6. Splitting it into two separate questions. 7 minus 2x less than 6. And yet again, too many ands on this. So many ands, not enough ors. All right, and 7 minus 2x less than negative 6. Let's subtract 7 on both sides. I'll show the work here. Negative 2x less than negative 1. Subtract 7 on both sides. Negative 2x is less than negative 13. Divide both sides by negative 2 on both equations. I did it again. I didn't flip it yet again. Look at this. Look at this. I made a same exact mistake. Mr. Richards, get it together. Divide both sides by negative 2. When you do divide by a negative, you flip the sign. Let's do it in decimal. 0.5 x. Now you do flip it again. You get 6.5. And the word and is in the middle. 0.5. 6.5. Okay. There you go. That's an open circle, by the way. All right, beautiful. Just a couple more questions, only 4 more to go. Let's get them done. We're almost here. How many minutes in? We're 28 minutes into the video. That's not too bad. All right, let's keep it going. So now I think it's a great time to introduce that U into it when we have too many things going on, all these negatives everywhere, letter U, all this kind of thing. Here we go. Let's do the U is equal to absolute value of r minus 3. And I think this is a great time to teach a cute little trick. 9u minus 9 less than negative 18. So this is a cool trick you can do on a question. This is totally optional. You do not have to do what I'm about to do here, but it does make the question have smaller numbers everywhere. It doesn't really speed it up, but it can speed up future questions. So you might notice that all these guys are divisible by negative 9. And because all of them are divisible by negative 9, just like how we do when we multiply everything by 6 or multiply everything by our least common multiple, if we can also divide if we wanted to. So if I divide every single thing by negative 9, you wouldn't normally show this work, but if I did, I would get u plus 1 greater than, flip the direction, positive 2. And now it's a really, really easy question to subtract 1 on both sides. I don't know, just a cute little thing you could notice if you wanted to. Either way, we still have to finish the question. We combine these two together. Even if you solved it normal, you'd end up at the same exact spot. Split it into two separate questions, r minus 3 greater than 1, or r minus 3 less than -1. I finally remember to switch that sign. Look at that. Look at me go. Add 3 to both sides. Get r greater than 4. Or add 3 to both sides. R is less than 2. The word or there. So these guys are actually really close to each other, 2 and 4, right? So 2 and 4. And you have to be greater than 4 or less than 2. Cool. All right. Number 10, same idea with this letter U. We're going to have 8 minus 9U greater than -55. Yet again, you got to write that U is equal to absolute n plus 3. Good idea to write it. We'll start off by subtracting 8 on both sides of the equation. We're going to get -9U is greater than -63. Divide both sides by -9. And we're going to get U is less than 7. And replace, because U is this n plus 3, so n plus 3 absolute valued less than 7. Split it into 2 separate questions. So we get n plus 3 is less than 7, and n plus 3 is greater than 7, negative. Really running out of room here. Subtracting 3 on both sides, we get n less than 4. Subtracting 3 on both sides, we get n greater than -10 with the and. So for our final answer, I'll do my graph over yonder. And we get a 4 there. Oh, now we get a -10 there. -10 is smaller than 4. And the word and tells us they meet together. Greater than -10, less than 4. Sure enough, they do meet. And finishing it up, our last 2 questions of the night. Let's power through it. Number 11, actually easy enough not to use letter U. Just subtract 3 on both sides. Hopefully that one's kind of clear enough. But if it's not, it's okay to use letter U. Nothing wrong with that. Less than 23. Split that bad boy into 2 questions. 5x plus 7 less than 23. If you forgot why we are putting the word and here, anytime alligator eats the number, becomes an and. If alligator's eating absolute value, becomes an or. And 5x plus 7 is greater than -23. So don't forget to flip that sign. Subtract 7 on both sides. You get 5x less than, looks like 16. Divide both sides by 5, and we get x is less than, let's use decimals, 3.2. Subtract 7 on both sides, you get 5x is greater than -30. Divide both sides by 5, we get x is greater than -6. And the word and coming in between there. So for our final answer, we got a -6, we got a 3.2. Open circles, they meet in the middle. Perfect. Last problem. We're almost there. All right. So let's do it. We'll make U equal to 6 minus 8b with the absolute values. We get -U minus 4 less than -30. We'll add 4 to both sides. -U with the plus 4s less than -26. Using that cute trick from the previous one, if we have negatives on both sides, we can make them both positive, but because it is a less than, it has to become a greater than, because you're flipping that sign, you're multiplying by a -1. Replace the U, 6 minus 8b, greater than 26, split into 2 questions. Don't want my face to block it. I don't want this other problem to be part of it either. So 6 minus 8b greater than 26. Or 6 minus 8b less than -26. Subtract 6 on both sides. -8b greater than 20. Divide both sides by -8. And you get b is less than -2.5. Or coming down, subtract 6 on both sides again, -8b less than -32. Divide both sides by -8, and you get b is less than, greater than 4. You gotta flip the sign because you divide by negative. Put them up. We got the -2.5. We got the 4. We got the open circles. We're going apart. Heck yeah, we're done. Hopefully not too bad. Have a wonderful rest of your day and wonderful weekend. If I don't see you, peace out. Boom, boom, boom.